In section 1.1, let's discuss statistical and critical thinking. I will introduce some concepts in statistics. Maybe you have already heard about those concepts before. I will give you the definitions and examples, and hopefully you can understand those concepts better. The first concept is called data. This is a very broad concept and it contains a lot of things. Data are defined to be collections of observations, including measurements, descriptions, and survey responses. So essentially, everything you have for data analysis will start from the data. If you measure the weight, the height, the lifetime, or length, you will get some numerical values. That's data. If you describe something using words, for example, sky is blue, grass is green, that's also data because you have descriptions. Or in survey questionnaire, you give responses, and that's also data. Here I give you 4 examples. There are way more than these. Suppose there are 5 quiz scores for the semester, and your scores are 89, 67, 91, 88, and 75. So that's a data set with only 5 values. And then you can use these 5 values to do analysis to see if you are doing a good job. In the second example, your cat weighs 8.5 pounds. That's also a measurement. You measure the weight. And using this number, you can see if your cat is overweight or not. So that you can do something with this very small data set. The list of most popular baby names. There are many baby names. And you'll get a really long list. And you may also have the frequency for each baby names. Like how many babies have name Emma or other names. So that's also some measurement. And then you can use this data set to see if the popularity of the baby names change with time. The last one, the responses from a survey on whether the president is doing a good job. So this is a survey questionnaire, and different people have different opinions, and at the end of the day, you will get the responses, how many yeses, how many no's, and so on. And then you can use those responses to do data analysis. And you can see that a data set could be a very small one with maybe 1 or maybe 5 values, or a big one with thousands or even millions or billions of observations. And I believe you have heard about this big data somewhere, right? It's everywhere. It's on the news, on the internet. Everyone is talking about big data. So essentially, if you have data or big data, you need to use some statistics methods, then get something out of the those numbers or responses or those descriptions. So that will be the topic of this class. So the next thing will be, what is statistics? It's a subfield of mathematics. Because here, the statistics group is in the math department, so it's part of mathematics. It's a science of planning studies and experiments, of obtaining data. So that will be the first step. How do we get the data? Because if you don't have any data, you cannot do any analysis. So first, you must have some data using some methods. And then once you have the data, you can organize, summarize, present, analyze, and interpret the data set using some statistical tools. And finally, you can draw conclusions and present your result to other people, and that's what we cover in statistics. So here, I give you some steps. First, the first step is to get the data, maybe through a survey, maybe through some measurements. And then you get some messy data set with a lot of numbers. They may not be very clean, so you have to clean the data to have some organized tables um, like this. And then you have to use some statistic methods. And this is our textbook. And you go to the book, find some appropriate methods or relevant algorithms. Then use the formulas like these. But don't worry, we wouldn't use very complicated formula. We use the simple ones because this is introductory course. So after you use the formulas, you will get some nice plot, some nice graphs, and you need to present those graphs to other people. And then you need to draw conclusions based on your findings. So that's basically all the steps in statistics. And we'll cover most of these. Now, first, let's go through another new concept called population. I believe many people knows what a population is. Right? It's just a group of people. The population of the city, the population of the state, the whole country, or the whole planet. Right? Depending on your scale, you could have different populations. In statistics, a population is defined in a very similar way. It's the complete collection of all measurements or data that are being considered. It may not be just people. It could be trees, houses, or other things. But it's just everything you have in your study. That's a population. And depending on what you want to find out, you will get different populations. For example, if you want to know the percentage of students who live off campus at FAU, maybe the administration of the university want to know if new buildings need to be built, new dorms need to be built, or maybe new cafeteria if many people live on campus. So in this case, the population would be all students in the school, because everyone will contribute to the percentage. Right? If you move from on campus to off campus, you change this percentage a little bit. So the population is everybody. And the size of the population in this case is about 30,000. We know the size of the population in this case. In another example, if a family wants to go somewhere for vacation, and different members have different opinions. Someone wants to go to Hawaii, someone wants to go to Alaska or California or some other places. So each one has a response, and the population is all family members. Right? Everybody has their own ideas. Excuse me. And in this case, the size of the population is not very big, maybe 3, maybe 5, but it wouldn't be like 30,000. So you can see that the size of the population could be small or big, and depending on the size of the population, you have different ways to get responses. Excuse me. If the size is not very big, you can do a census. So basically, you have responses from everybody in the population. So this is doable for the family example. Everyone will speak their will speak out their desired vacation place, and you get a census. But this may not be plausible for the off-campus students example, because you have more than 30,000 students. It will take a very long time to collect the data. So in that case, we may need to do a sample. So census and sample. A sample is basically a sub-collection of the members from the population. So if you look at the cartoon on the lower right corner, the population is a big circle with many individuals. And there are so many, so we cannot observe everybody. So what we do is we choose some from the population and form this small circle of sample. Once you have the sample, you can observe everybody in the sample because it's not big. So you can do, a complete measurement of the sample. And then remember, your goal is still about the population. So this is still your goal. But once you know your sample, and ideally, if your sample is a good representation of the population, which means the population and the sample are very similar. The only difference is their sizes. The population is bigger, the sample is smaller. But if they share some common properties, then whatever you learn in the sample could be used to describe the population. So you can go this way. And that's what we call statistics. However, if the sample is not a good representation of the whole population, then you cannot do that. For example, you want to know the average height of students at FAU. When everyone has a height, you want to know the average of all 30,000 students. That's too many, so we draw a sample. We say we choose 10 students, and we choose 10 students from the basketball team. And we know they're all very tall. So the average of the students in the sample is big. But that's not what we have for the whole student body, right? The average from the sample is much higher than the average of the population. So the sample is not a good representation of the population, and whatever you learn from the sample cannot be trusted. You cannot use the property of the sample to describe the property of the population. So be careful about that.